This is experiment 2, the voltage measurement and the reference ground. And here are the supplies we needed for experiment 2. I have 3 resistors, a 100 ohm resistor, only need one, and a 1 kilo ohm resistor, and a 300 ohm resistor. I have a brand new 9 volt battery, a wire trimmer, a breadboard. You may use different breadboard, but the way to use it is same. A multimeter, and then the probes. You can use different kinds of probes, and that doesn't matter, not very important. And here I have some wires. I also have this 9 volt battery snap there. So the first thing, there's no particular order, but we need to measure the real values of the source and the 3 resistors. We need to use the real values, not the expected or theoretical values. So how about let me begin with measuring the voltage of this battery. So there are multiple ways to do it, more than one way to measure the voltage of it. I'm going to show the simplest way. And so let me put this battery maybe here, right? Let it stand up and then turn on the meter. Since we know battery provides DC voltage or DC current, DC voltage, so we need to spin the knob to the DC voltage feature or option to measure its voltage. So spin that to here. And now grab the probes. This is the positive terminal of the 9 volt battery, so the other one is the negative terminal. This meter has these cables connected correctly. The red cable connects to the thing that we are going to measure. Over here, that case is the voltage, and the black cable connect to ground. So we can use this to attach to the positive terminal, such as there. Make sure to hold it tight and place that probe, the metal piece, to the metal part of the battery, and then take the other one there. So as you can see, the reading here is 9.42 volt. There, 9.42 volt. Make sure to write down this number to table 1. This is the measured power source voltage. After using the battery for a long time, the voltage decreases. For this experiment, the voltage source should be around 9 volt. If it's a little bit higher or lower than 9 volt, that's fine, such as between 8.50 volt to 9.50 volt. Otherwise, should change the battery. So this is good. This is the experimental, also called measured value for the source, the real value. So let me remove these probes and then connect the snap. How about before that? Let me show something else. Right, earlier we put the red probe there and then the black probe here. Yeah, and then we get a 9.42 volt. How about let's swap this? So what should be the voltage reading there? Let's see. It has polarity, and let's see. It is negative 9.42 volt. Yeah, so it has polarity, the direction or the orientation, right? The place we put the probes is important. We should put this to the higher voltage, which is the positive terminal, and then the black probe connect to the negative terminal. So to get a positive reading here. Okay, let me put these probes aside, and now connect the 9-volt battery snap to here, to there firmly. There we go. So it's connected. It's ready to use. Make sure terminals, the negative and the positive terminals, don't touch. Yeah, do not touch those metal pieces. Do not form a short circuit. It's dangerous, even for 9-volt battery. Now we are ready to build the circuit. The next step is to measure the 3 resistors values. We need to get their experimental so-called measured values using multimeter. The measuring process is not shown here. If you forgot how to measure the resistance, refer to experiment 1. Once you get the 3 resistors measured values, write down these values into table 1. So there are no particular order for connecting the circuit, but if you look at the schematic showing in figure 2, maybe we can begin installing the 300 ohm resistor. That is here. So let me take that resistor, that one, and then start to cut these extra long legs, because later we're gonna bend those legs and insert it to the breadboard. If it's too long, we just cannot place this all the way. That can break the board. So I would just cut the wires maybe to about there, and then cut the other leg maybe about the same length here. So now I have a resistor with 2 legs about put that here. And you can also use a tweezer to grab the resistors. So take that one. Right, this one is a orange, black, brown 300 ohm resistor. So I'm gonna bend those wires, the legs, there, or here, perhaps it's easy to see it, and then start to insert it. We can place the resistor almost anywhere on the breadboard. So I'm not going to put this all the way to the left, which is at the beginning of the board, because sometimes we need to put some extra wire here for connecting different regions, maybe the first 2 rails on this side, or those rails, those lines on the other side. So I just put it maybe around here, such as line number 10, 11. There's no right or wrong. I will put it at here. There. And next, I'm gonna connect the second resistor, R2, 100 ohm resistor. That one. This one. So the color band is brown, black, brown, 100 ohm resistor. So I start to cut it. You can make the legs longer or long or short, so that's up to you. I will cut it about this long. There. Here. And then bend the legs. There and here. Now I'm gonna put this on the breadboard, such as that. Put this there. So the legs are between line 15 to line 20 or 19 in this case. You don't have to put the resistor here, or you can connect from here to there, so that's up to you. As long as resistors are connected and we are building the correct circuit. So the third one, if you look at the figure 2, the first resistor is that. The value is 1 kilo ohm. So I'll do the same procedure, cutting those wires or legs, and not too long. Maybe I use the same length as before for those two resistors. So that, yeah, the other side is longer, so let me trim off that longer portion. And now I have this resistor. And same as before, bend those legs, the other one, and then insert it. There. So let's recheck. So resistor R1, the 300 ohm resistor, all the way to there. This one, this leg and that leg are in the same vertical line at line 15. So they are connected. And then that's the second resistor, the 100 ohm resistor. This leg of that 100 ohm resistor connect to that leg of the 1 kilo ohm resistor. So they are connected in series. And that's the other side of the third resistor, the 1 kilo ohm resistor. Now we just need to connect here to ground, the blue line. This connects to the positive voltage there. Later, this line connects to the positive terminal of the source. The other one connects to the negative terminal of the source. So now we're gonna grab some wires. Make sure follow the color convention. Take the red wire and then maybe cut about that long. This long. And then start to trim the extra part, the protector of this wire there. So over here. So this way I can put this wire from here to there. So I bend that legs of the wire and that leg and put this, right, insert that wire over there. So between here and there we go. So this side of the resistor, that 300 ohm resistor, connect to the red wire, and this entire row connect to the positive terminal of the 9-volt battery. And let's take the black wire here, maybe about that long, and then let's trim off that protector. Okay, there we go. It's about that long. Bend those wires. The other side. Put this over here. There. And this is the last resistor, R3. So the end of that resistor connects to the black wire, and the black wire links to the blue rail, blue line. And then the blue line over here connect to the negative terminal of the 9-volt battery. So to make the connection easier, so I'm going to cut additional red wire with that, trim off here, and then remove this part of the wire, insert that here. Same as the other one. get a piece of black wire. Use the trimmer wire cutter to remove this part of the protection and that, and now put this here. The reason is we are going to connect that over there. Make sure they never touch, never ever. We don't want to have a short circuit. So put this here and put this alligator, right? Open that alligator clip and then click on this wire. There we go. Now we have a power source provide a voltage to this closed circuit. The next thing we are going to do is to measure the voltages. If you look at the table 3, or let's look at table 2. Step 4, we need to measure VA. VA, set the meter to the voltmeter mode. Connect the voltage probe to point A, and then connect multimeter's ground to the ground of the power supply. So that is between here and there. Since we measured that already, but this step is same as the previous, just for measuring the source, we expect to see the same reading. Let's confirm. Connect that to there. Oh, sorry. This to the red part. Connect that to here. And as you can see, the reading now is 9.28 volt. 9.28 volt. And write this down. Write down this number. This should be VA in table 2. Now we're gonna measure B, right? VB. So VB is between point B, which is the other side of resistor R1, to the ground. Right? Ground is still here. Don't change. It doesn't change. We just need to measure a point from here. This point is point B. To make measurement easier, I'm gonna trim off a green wire here. Cut a piece of green wire. Put this wire here. This is point B. Point B is between R1 and R2. The 300 ohm resistor and the 100 ohm resistor. So this is point B. I'm gonna disconnect that, put this here. Now we get a reading that is 7.25 volt. So 7.25 volt is for VB in table 2. For VC, right, point C is between resistor R2 and R3, this junction point. This is C. So I'm gonna remove this green wire, this one, and then put that here instead. So this is the value for VC. Right, VC's reading is 6.590 volt, 6.589 volt now. So write down this number. This is VC in table 2. And at the end, we need to measure VD. So just remove this wire, right, unplug it, and then place that to D. This is at D. Here. So there, this is 0 volt. Therefore, VD in table 2 equals to 0 volt. Now we're gonna move to the next step. we're going to complete table 3, step 5A through D. So if we look at step 5A, measure Vs, leave the ground black probe unchanged, connect the meter, the red probe, to the voltage source. So source is there. And we can unplug that, place that here. The source voltage is 9.27 volt. It drops a little bit since this energy is being consumed. So we do expect to see some voltage drops. It's not the original voltage anymore. Through the time, it will be decreased little by little. It will be decreasing until we use up its complete energy. So Vs is 9.27 volts for table 3. And then now let's look at VAB. VAB is the voltage between point A, which is here, point A, and point B, there. So VAB will begin with A, so the red probe connects to point A, there. And then we need to measure or place the other probe to there. So how about, let me just cut one more piece of wire. Put that here. So this is this is point A, this is point B. Place this probe over there. The reading now, this is 2.020 volt or 2.020 volt, is VAB's voltage, where a VAB is V, the voltage A from A to B. So VAB equals to 2.020 volt. And now we need to move to or measure VBC. So this point is B, that point is C. So we need to unplug that wire. Maybe unplug that. Put that over here. How about this? Put this wire there. This is at point C. And then unplug that, put this there. This is at point B. So the voltage we are measuring now, that's 0.660 volt, is VB to point C, so VBC. VBC equals to 0.660 volt. So we can fill in this number to table 3 for VBC. One more, that is VCD. So let's say we can unplug both wires. From C, this is point C, and the point D is there. Point C, this point D at that point. The voltage reading is 6.575 volt. Therefore, VCD, the voltage across that resistor is 6.574 volt. So put this number into table 3 for VCD. Now we complete these steps in the table 3. For step 6, we need to find those numbers, VABCD, and the ground is at point D. This is the ground part. If you look at the schematic, figure 3, ground connects to point D, and then we just need to move this wire to different points and then measure the voltage from that point to the D. So let's do it. VA, so unplug that, move it to point A, right? This is point A. The voltage is 9.25 volt. Record this number. So VA in table 4A equal to 9.25 volt, which is the source voltage, the battery's voltage. Now unplug that, put this to point B, right here is point B. The voltage is 7.23 volt. We are measuring the voltage drops on both resistors here. Overall, for these two resistors, they together takes 7.23 volt. So VB, right, VB measuring the voltage across this and that resistor. It is 7.23 volt. Write it down in the table, table 4A VB, and then unplug that, put this to point C. And we can put this wire there, this point, or even the one above here. They are all in the same line, same column. So voltage is 6.567 volt. Write it down, put it into the table 4A for VC, and one more VD. So place this to point D. Yeah, obviously equal to 0 volt. Yeah, because there's no resistors between this and that wire. Right? They connect together, no resistors in between, so no voltage drops. So that's 0 volt for VD in table 4A. For table 4B, we need to do calculations. No measurement needed for table 4B. And then now let's move to figure 4 for table 5A. Step 7. And now, right, how about let's unplug these two wires. This time, the reference ground is not at that point anymore. It is at point C here. So we place this wire over there. This is our new reference ground. We will measure the voltage referred to here, right? This is the ground. And now, for VA, place the other side of the meter probes to point A. The reading is 2.672 volt. The voltage between this and at that point, which is the voltage drops on these two resistors. These two resistors between those two probes. So VA equals to 2.672 volt. Now unplug here and measure voltage at point B. Refer to this point. There is our reference ground. So the voltage equal to 0.658. So VB for table 5A equals to 0.658 volt. Now let's do for VC. Place this wire, this pin here at point C. Since there's no resistors between these and that probes, equals to 0 volt here. That makes sense. Now unplug that one and then put this to point D. Here is point D. Put that there. We get a negative reading. That equals to negative 6.557 volt. And this is correct. VD equals to a negative number. It is negative 6.557 volt. So write this down, put this to VD in table 5A. Now let's move to step 8. For step 8, we change the reference ground location again. So it's better to unplug both of them and then put this to the point B in this case, right? Point B is the reference ground. This is point A, that is point B, so I put that here. There. And the first one in the table 6A is for VA. So move this pin or plug in this pin to point A over here. VA equals to 2.011 volt. Write it down, put it into table 6A, and then unplug here, put it to point B, that is the VB in this step. VB equals to 0 volt, because there's no resistors between these two probes. And then move to the next one, VC, unplug here, and then put that there at point C. At point C, we get a negative 0.657 volt. And then write this down, VC equals to negative 0.57 volt, or negative 0.657 volt. Now let's move to point D, or VD. Unplug that, put that to point D. VD equals to negative 7.21 volt. Write down this number, that is VD in table 6A, or step 8. And we have one more step. That is to put the reference ground at point A. So it's better to remove or unplug other wires. Unplug this as well and put this to point A. Here. Okay, now let's start measuring all these required quantities. First one is VA, which is this probe connects to point A. So I can put that there. Obviously, it's 0 volt since there's no resistors between these two probes. Now let's move that to point B. Unplug here, move it to point B. We get a negative 2.009 volt for VB in this case, or VB in this case. It's the voltage measured from this point to there. So voltage is negative 2.009 volt. Unplug that wire, put it to point C, so we measured VC in this case. VC equals to negative 2.665 volt when the reference ground is at there, point A. Again, in table 7A, VC is negative 2.665 volt. And then unplug here, put it to point D. We get a negative 9.21 volt. In other words, the voltage between these three resistors and the measure is from there to here is negative 9.21 volt. So this is the end of experiment 2. Make sure record all the numbers.